Hello guys, how are you today? So today I'll be explaining the chemistry AMS of Term 1 Week 1 Grade 11. Now this is a recap of Grade 10 chemistry, everything we've taken. There is though one specific question, I think it's question, I don't know, I cannot see the numbers by the way, I think it's question 18 or 17, that is, we haven't taken it before, so I had to do a bit of research before in order to be able to explain it. Now, I don't think it's coming. If it does come, in all cases, I did my research and I'll be able to explain it. Now, I do apologize for my setup. I don't know what happened. I know the screen is a bit smaller. I'll try to zoom in. For some reason, I'm not able to see my full screen. So if anyone could please help me on how to zoom out even more, because I just did this from the settings. I want to know how to zoom out more from Chrome itself. If you guys could help me, that would mean a lot. Thank you so much. So anyways, enough talking. Let me get back to my video. So, which of the following mixtures are best separated into its components using what? Simple distillation. Whenever you hear the word simple distillation, you have to directly think of what? You think of a salt, okay? Or sugar. A salt or sugar. Plus what? Plus the liquid, right? Why? Because the salt or sugar will dissolve or become aqueous in this liquid, and you can separate them, of course, by something called simple distillation. So in this case, oil and water is wrong. Oil and water can be separated by so you can separate oil and water by using a separating funnel. Water alcohol solution. Because water and alcohol both have really close boiling points, we will not use simple distillation, we will use fractional distillation. Sodium chloride, which is a salt, aqueous solution, yes, for sure, you can separate it using simple distillation. Sugar, salt, water solution. Okay, here's the thing. Sugar, salt, and water solution, both sugar and salt dissolve into water. So after you do simple distillation, you will get water, but sugar and salt are still together, and that's a bit harder to separate. So definitely, for sure, this is wrong. Sugar, salt, and water solution is wrong. How do we separate it? We separate it by the selective solubility, I think it's called, where we put alcohol first of all. Why do we put alcohol? Because sugar can dissolve in alcohol, whereas salt cannot dissolve in alcohol. And then we filter it, so we have the salt by itself, and the sugar and alcohol mixture is one. Then using simple distillation, we'll be able to separate the alcohol and the sugar. So that means sugar sugar alcohol solution is to be separated by simple distillation. So it's sodium chloride and sugar alcohol solution. We move on to question number 2. Which of the following is the electron configuration of sodium atom Na11? Now here they said what? They said sodium atom. Pay attention. Sodium atom means it has to be what? It has to be neutral or no charge. In this case, it is Na11. So that means it has no charge because it's a sodium atom, right? So you will do the configuration for the 11, and it's gonna be what? It's gonna be 2, because in the first shell we always have 2 electrons. Then 8, because in the second shell we always have 8 electrons. And then finally, in the last shell, we are supposed to have 8 electrons, but because we only have 1 left, we will put 1. Now, if you add them all together, 2 plus 8, 8 plus 1, you will get a total of 11, which is what? Which is the number, the atomic number of sodium. So the answer over here is 281. We'll move on to question number 3. The following shows the chromatogram of a dye that was separated into 3 components, A, B, and C, using paper chromatography in a solvent X. Choose the component of the dye that is least soluble in the solvent X and has the most affinity to the paper. So, what does it mean? Least soluble in the solvent X and has most affinity. First of all, when you see these two, they are related to each other. If something is less soluble, that means it has more affinity. If something has less affinity, that means it has more solubility. So, in this case, in this solvent, the more soluble something is, the farther it will travel, right? So, in this case, C is the closest to the baseline, or traveled the shortest distance. Because it traveled the shortest distance, it means it is what? It is the least soluble. And because it is the least soluble, it has what? It has the most affinity to the paper. So the answer for this question is C. We'll move on to the second part. Give the RF value for component A. I still hope you do remember how to solve for the RF. So how do we find the RF for component A? It is very simply the distance from the baseline. Very important. From the baseline, okay? The distance from the baseline to the point, this is 10 centimeters, divided by the distance of the solvent front from the baseline. So in this case, it's 10/12. Put it on your calculator, and you will get an answer of what? Of approximately 0.83. So the answer over here is what? It's 0.83, which is the RF value. It has no unit. We move on to question number 4. We have 4 test tubes, and they did experiments for all of these test tubes after adding what? After adding AgNO3. Based on these experiments, we should know what has been, like, what is the ion based on what we observed. So, observation of test tube A, yellow precipitate. Whenever you see yellow precipitate, you directly think of iodide or I-. I remember my friend once told me how to remember it. Yellow, Y, it sounds like I, so YI, iodide, very simple. So that is it for test tube A. We'll move on to test tube B. Okay, in test tube B, formation of white precipitate that turns to violet then black. When you see white precipitate then turns to violet or black, or only white precipitate, whichever of these, you will directly think of which ion. You will think of the Cl- or the chlorine ion. Right? So for test tube B, we have the chlorine ion. For test tube C, it is what? It's the formation of a creamy precipitate. The keyword here is creamy. Whenever you see a creamy precipitate, you will know what? You will know that this we are talking about is the bromine or the bromide ion, which is Br-. Now for the last one, it is what? It is no change. Whenever you see no change, you directly think of F-. So again, you see yellow precipitate, Y, yellow, I, iodide, so it's the iodide ion. When you see white precipitate, you directly think of the chloride ion. When you see a creamy precipitate, you directly think of the bromide ion, and if there is no change, then it is what? It is the fluoride ion. We'll move on to question number 5. So here you have to pay attention to the keywords. We have sulfurized fuel, so for sure it's going to be sulfur dioxide. Now, for example, let's say I don't know what this is. I'm going to leave it for the end. In this case, I don't know what it is. I'm going to leave it for the end, right? Complete combustion of carbon-containing fuels. Here's a hint. When you see complete combustion, it's CO2. When you see incomplete combustion, it's CO, right? So complete combustion, 2 C's, it's CO2. So complete combustion, CO2. And incomplete combustion, it's only CO. So CO2 is carbon dioxide, and CO is carbon monoxide. Now, whenever you see animals, think of like cows when they release gas, okay, or like the decomposition of any plants or any vegetation, this will release something called methane, right? So the gas released by animals or the decomposition of vegetation, it is what? It is methane. Now finally, I have all of the answers put in front of me. What's the only one I did not put? Of course, don't put water vapor. Water vapor has nothing to do with any of this. So I put carbon monoxide, I put methane, I put sulfur dioxide. What's left for me is the nitrogen oxides. So this is how we're supposed to think of it in the exam. Now just in summary, sulfurized fuel is sulfur dioxide, internal combustion engine or jet engines is nitrogen oxides, complete combustion is carbon dioxide, animal digestion or decomposition of vegetation is methane, and incomplete combustion, it is what? It is carbon monoxide. Now, select the correct dot and cross diagram for the given compounds. Now, first of all, if you remember from last year, we have a different diagram for the covalent compounds and for the ionic compounds. Again, what are covalent compounds? Covalent compounds, I'll just call them CC. Covalent compounds, they are what? They are when 2 nonmetals form a compound. Of course, not only 2 nonmetals, 2 or more, like nonmetals, form a compound. This is a covalent compound. They will form covalent bonds, or in other terms, they will share electrons. Whereas when we are dealing with the ionic compound, which is IC in another term, it is when a metal and non-metal exchange, here's the key word, exchange electrons. Usually, who gives the electron? Usually the metal will give the electron to the non-metal. This means what? This means the metal will always have a positive charge because it's losing electrons, and the non-metal will always have a negative charge because it's gaining electrons. Now, of course, in these examples, let us see. First of all, we have H and F. They are both what? They're both non-metals, so they're forming what? They're forming a covalent compound. As you can see, they are accurately sharing their electrons. My bad, I accidentally cut off the other video. So as you can see over here, H and F, they are sharing the electrons. How do we know? Take the ion, for example. H, what's the ion of H? It's H plus. What about F? What's the ion of F? It's F minus. طيب, what does this mean? This means, very simply, that H, okay, has one electron to share or give or take. Okay, I'm not gonna say anything for now, just let's say share. It has one electron to share, and F has only one electron to share as well. So in this case, you will have one electron from hydrogen, one electron from fluorine, and in this gap over here that they both share, you will have how many electrons? You will have 2 electrons. Now let's do the SH, okay? So again, let's take their ions. H is H plus, and S is S2 minus. You guys by now should know the ions totally by yourselves. So what does this mean? This means that hydrogen has only one electron to share, whereas sulfur has 2 electrons to share. So in this case, what did they do? They got another hydrogen. So as you can see, each hydrogen is taking one electron from the sulfur, okay? And there's only one sulfur, so the sulfur is sharing both of its electrons, and the hydrogen is also sharing, like each hydrogen is sharing their single electron, and together how many do they have? They have 2 electrons in the shared space. Now let's move down. Here we have an ionic compound. How do we know that this is an ionic compound? Because it has Na, which is a metal, and I, which is a non-metal. So Na, the metal, I is the non-metal. Take their charges. Na is always Na plus, and I is always what is I minus, right? Now here, if you look, you have Na plus, right? And how is it represented? It's represented as a full circle. Why? Because in the last shell, it gave away its electron. Again, we repeat, Na is a metal, right? So with this metal, it's gonna give an electron. It gave the electron to the I, because I is a non-metal. And because of this, in the last shell, it will have no more electrons. That's why it's only represented by a circle without any electrons. Now, regarding the I, how many electrons did Na give the I? It gave it only one electron. And if you look at the diagram, okay, you will see that there is 1, 2, 3, 4, 5, 6, and 7 electrons that belong to I, but only one electron belongs to Na. How do we know? Because it's an X, okay? X means that it belongs to Na. طيب, in this case, it gains one electron. What will its charge become? Its charge will become positive 1, but as you can see over here, it's 2 positive. That means this one is a wrong answer. We will not choose it, okay? Now, I believe this one I can skip it because it's the same as this one and this one. Whereas and as you can see, it's correct either way. I'm just gonna explain this one and then I will move on to the other questions. Now, Mg is what? Mg is a metal. And fluorine is what? Fluorine is a non-metal. So what type of bonding will we have? We will have an ionic compound or ionic bonding. Now, of course, you have to remember their charges. Mg is always going to be Mg2 plus, and fluorine is always going to be F minus, right? So Mg is going to give 2 electrons to the fluorine. But here we have kind of a small problem. If Mg will give us what? Will give us 2 electrons, and fluorine can only take 1 electron. How can we make this work? Yeah? So very simply, in order for us to make it work, we just need to add a 2 over here. So now what happens? Mg will give 2 electrons, okay? But it will give 2 electrons to 2F, to 2 fluorines, right? Because each fluorine can only take 1 electron. And with that, you will have what? You will have that the Mg gave both of its electrons to both the fluorines, and it has a charge of what? It has a charge of 2 plus because it gave 2 electrons. And each fluorine will have what? A charge of minus. And this minus indicates what? Indicates that it took a charge. So very simply, these 4 are the correct answers. Let's move on to question number 7. The correct physical properties of metals. Metals are good conductors. They are not brittle. They are hard. They have high melting points, high boiling points. They are good conductors. They are malleable and ductile, meaning they can be turned into wires, they can be flattened, bent, whatever you want. And that's pretty much it. Diamond and silica form giant 3D structures. Choose the correct answer to complete the following. Now, of course, diamond and silica, they both have the similar structure. What is made of carbon? Diamond is made of carbon. Silica is made of Si and O2. So it's made of Si. What's Si again? Let me just check. It's made of silicon and oxygen, right? So diamond is made of carbon and silica is made of silicon, is it? Yeah, silicon and oxygen. Now, both of these, they are like hard, strong materials, and these materials, they are what? They are strong. The atoms of these materials are held together by strong covalent bonds. We all know that diamond is one of the strongest minerals on Earth, and this is due to the covalent bonds, the very strong covalent bonds that hold the atoms together. Now, this is a very important question. The electrons in these giant structures are localized. Electrons are only delocalized if it is a conductor. For example, graphite is a conductor. That means it has some electrons that are delocalized. Why? What does it mean to be delocalized? It means they can move freely, and due to their ability to move freely, they are able to move the current from electron to electron, and thus it is what it is, a conductor. Whereas in diamond and silica, they are localized, they're not allowed to move freely. So when you touch, for example, a diamond with electricity, you will not get a shock because the current will not pass through it because a diamond is not a conductor. We'll move on to question number 9. So what did we get rid of from this step to this step? We got rid of the large solids. So this is gotten rid of by screening. Then from this step to this step, bacteria. This is the sanitization, I think, if it is even a word. And then here we got rid of the fine solids. So this is the filtration. So let us check. This is screening, this is sterilization, and this is filtration. Now, which step involves the addition of chlorine or exposure to UV light? Very simply, you know that chlorine and UV light kills what? Kills bacteria. And in which step did we remove the bacteria? We removed the bacteria when we went from this step to this step, which is basically which path? Basically, it is path B. So from step B, okay, we added chlorine and we got rid of the bacteria. We'll move on to question number 10. Here, this is all about the key words. The metal to be protected is connected to a more reactive metal. Whenever you see a more reactive metal, you will know directly what? Directly, this is gonna be what? This is gonna be sacrificial, because you're sacrificing one metal instead of the other. This is known as what? Sacrificial protection, right? Now, the metal to be protected is coated. If it is coated, then this is called what? This is called electroplating. So, if it's a more reactive metal, it's sacrificial protection because a metal is being sacrificed instead of the other one. If it's coated with another metal, this is known as electroplating. And then zinc, directly you will see it as galvanizing. I don't know if you guys see this random video that pops up while you're like watching on Instagram or TikTok. And he needs to fit in the toilet, for example. He wants to sleep in the bathroom. So he will build a frame made out of galvanized steel. Basically, galvanized steel is what? It's metal that is coated with zinc, right? So when the guy wants to make his room in the bathroom, he's coating the metal with zinc in order to be able to sleep in the bathroom, which I don't know why anyone would want to do that. So it's sacrificial protection, electroplating, and galvanizing. We'll move on to question number 11. Aluminum objects are not protected from corrosion, whereas iron objects are either painted or metal coated to prevent corrosion. Now, here this is very important. Why is aluminum not protected from corrosion, whereas iron is protected from corrosion? Very simply, aluminum is more reactive than iron. Because of the fact that aluminum is more reactive than iron, it will react quicker or faster with oxygen. And what happens when aluminum reacts with oxygen? It will form aluminum oxide. Now this coat of aluminum oxide is not reactive, so it will what? It will protect the aluminum that is inside. So it forms what? It forms a layer or a coat. So aluminum is more reactive than iron. It reacts rapidly with oxygen, forming a thin coat of aluminum oxide that prevents further corrosion. We'll move on to question number 12. Chlorine Cl2 is added to methane. Whenever you see methane, what is methane? Methane is an alkane. Whenever you see any alkane, you will know that the process is what? It's substitution. How do you speed up substitution? By UV light. This reaction is called substitution because, why is it called substitution? Because you're taking from, for example, the chlorine atom, you're taking one of the chlorine and you're substituting it instead of the hydrogen, right? So this is part A answered. The reaction between methane and chlorine can be speeded up by UV light. This reaction is called substitution because chlorine takes place of a hydrogen atom. Now, CH4, what's the structure of CH4? We have C in the middle, and we have 1, 2, 3, 4 H's, right? And then chlorine, it's what? It's Cl, Cl. What's gonna happen now is chlorine, okay, it's gonna take the place of one hydrogen, right? So the carbon stays in the middle, and then you have another hydrogen here, here, and you have what? You have a chlorine here. Now, what is important to know is that as long as carbon is in the middle, right? As long as carbon is in the middle and there is a substitution, meaning that you can have some hydrogens, but there's at least one chlorine taking the place of a hydrogen, then this is definitely gonna be a product. So what are the two conditions for it to be a product? There should be carbon in the middle and there should be a substitution, okay? Now, there's another product. Like if we substituted and we took the place of this hydrogen, it became chlorine. Where will the hydrogen go? It will come instead of the place of the chlorine, and it will be what? It will be HCl. So these are the possible products. We have HCl, of course. Remember, carbon has to be in the middle and there has to be a substitution. So these are the products. Now, propanoic acid reacts with ethanol, C2H O5, according to the below reaction, right? Again, what is this? This is a is that a carbo? Yeah, it's a carboxylic acid reacting with what? Reacting with an alcohol. Remember, whenever a carboxylic acid reacts with an alcohol, let me fix my handwriting. So, whenever a carboxylic acid reacts with the alcohol, it will give us a product which is known as what? Which is known as the ester bond. In addition to what? In addition to water. So in this case, we have what? A carboxylic acid reacting with an ethanol. So it will produce what? It will produce an ester. I think ester is like this, or no? Ester without the H. Ester bond. It will produce an ester bond in addition to what? In addition to water. Now, the name of the forward reaction, because we are producing an ester bond, it is called what? It's called esterification. Now, the backward reaction, because we are adding water, as you can see in the backward reaction, we are adding water. So because we are adding water, this is called what? This is called a hydrolysis reaction. Again, carboxylic acid plus alcohol, ester bond plus water. So acid plus alcohol is gonna form esterification, but ester bond plus H2O, it's gonna form what? It's gonna form hydrolysis. So the forward reaction, because we are producing an ester, it's called esterification. And the backward reaction, because we're adding water, it's called what? It's called hydrolysis. Now, we come to the naming of the products. I hope you remember how to name the products. Now, here's the thing. This is what? Our carboxylic acid, our Ca. And this is what? This is our alcohol, our A. In order to name the ester bond, okay, you're going to take the prefix, or how many carbons do we have in the alcohol? You will take the prefix, which in this case is eth. You will add Yl, okay? In addition to what? In addition to the number of carbons we have in the acid, in this case it's 3, you will take the prefix, which is prop, and then you will add anoate. So it's going to be ethyl propanoate. Again, in order to name an ester bond, it's going to be what? It's going to be, first of all, the number of carbons we have in the alcohol. You're going to take based on that, and you will add Yl. So we have 2, it's going to be eth, and then you will add Yl. In addition to what? In addition to the number of carbons we have in the acid, which is what? Which is 3, so it's going to be prop, and then you will add anoate. So it's going to be ethyl propanoate. Oops, I don't know why I have the caps on. Propanoate. Now, this was naming the product A. We come to what? We come to locating the structure or building the product A. When we named the product A, we put the alcohol first and then we put the carboxylic acid. But when it comes to making the structure, it's the opposite. It's the carboxylic acid first and then we will put what? Then we will put the acid. So again, when you are naming, you will put the acid first, the number of carbons of the acid first, and then the number of carbons of the carboxylic acid. But when you are building the structure, you will put the number of carbons of the carboxylic acid first and then the number of carbons of the acid. So in this case, our carboxylic acid first has 3 carbons, right? So you will go down and you will look which one has 3 carbons in the beginning. This one has 3 carbons in the beginning, okay? And this also has 3 carbons in the beginning. But now I will tell you which one is correct, right? Then, for the ethanol, we have 2 carbons at the end. If you go down, this has 2 carbons at the end, and this has 2 carbons at the end. طيب, Amanda, which one is correct? They both have 3 and 2. All you need to know is whenever you are dealing with the ester bond, you are going to be seeing this. If you don't see this, then it's not an ester bond. But if you see this, that means it's directly what? It's directly an ester bond. So which one of these is gonna be the ester bond? It's gonna be this one. Why? Because it starts with the carboxylic acid number of carbons, which is 3. Then it has the ester bond, okay? Then we go to the number of carbons of the alcohol, which is what? Which is 2. Now, choose the name of the carboxylic acid and the alcohol that react together to form compound B. Now, all you need to know is that if you're trying to find something that has the same molecular formula as another compound, it should have the same exact number of carbons. So, compound A is what we were discussing above, right? How many carbons does it have? It has 1, 2, 3, 4, and 5 carbons. So now we need to find something that has 5 carbons. This is meth is 1, so it's gonna be 1 plus 3. 1 plus 3 is 4. Bute is 4. 4 plus 2 is 6. Eth is 2, so 2 plus 3 is 5. Definitely C is an option. And then 2 plus 1 is 3. It's not an option. That means the correct answer is what? The correct answer is C. We'll move on to question number 14. The following diagram shows the diffracting tower used to separate petroleum into fractions. Let's go down. Choose the property used to separate petroleum into fractions. So, as you can see over here, we have different fractions, and petroleum is being separated. This, very simply, we call it what? We call this fractional distillation. Right? So, what is the property of fractional distillation? It is due to the difference of the boiling point. So the property used to separate petroleum into its fractions is the boiling point, because petroleum is made out of so many different things, but these so many different things have different boiling points, and if you boil each one at a specific boiling point, you will get what? You will get their resultant, like you will extract them. So this is basically the property of what? The property that allows us to separate petroleum into fractions. Now, the most volatile fraction, meaning the fraction that is like having the least boiling point, okay? The fraction that has the least boiling point is always the fraction on top. What's the fraction on top? The fraction on top is called fraction A. So again, most volatile fraction means it has the least boiling point, and the fraction on top is fraction A. Now, drag and drop the following to arrange fractions in decreasing order of boiling points. How do you know which one has a decreasing order of boiling points? Again, it's based on the fractions. The lower the fraction, the higher the boiling point. The higher the fraction, the lower the boiling point. Why? Because we said the one with the less boiling point will be more towards the top, right? So, if we're saying that the lower the fraction, the higher the boiling point, and they want us what? To arrange it in decreasing order of boiling points, then very simply I'm gonna start with C, because it's the lowest out of A and B, and then with B, and then with A, okay? Now, here you need to remember which one is like having the less boiling point than the other. First thing you need to know is that petroleum gas is in fraction A. It's the most volatile. It has the least boiling point. Then comes the gasoline, okay? After the gasoline comes the lubricating oil, and then finally after the lubricating oil comes the bitumen. So, fraction A is petroleum gas, then gasoline, then lubricating oil, then bitumen. This means bitumen is the heaviest. It has the highest boiling point. Okay, we'll move on to question number 15. So, tetrafluoroethene of the following structural formula undergoes polymerization, forming the polymer Teflon, right? Give the name of the type of polymerization ethene undergoes. First of all, ethene is what? Ethene is an alkene, right? Alkenes undergo addition polymerization. Very simply, this is how you do it, this is how you solve it, right? So, ethene is an alkene. Alkenes undergo addition polymerization. Give the chemical name of the polymer Teflon. Teflon, okay, also known as tetrafluoroethene. Its polymer name is very simply what? It's poly, and then tetrafluoroethene. This is very simply its chemical name. If you see, for example, XYZ, they want you to write the polymer of it. It's gonna be poly XYZ, right? So, it's gonna be poly tetrafluoroethene. You see on how many times we've written it? My keyboard has it memorized. Let's move on to part C. If n molecules of tetrafluoroethene are polymerized, locate the correct representation of the repeating unit. Okay, so here comes the part where we need to remember what we did before. We have C double bond C, F, 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 and F. This is the monomer. We need to change it into what? Into the polymer. So in order for us to change it from the monomer into the polymer, we will need to break the double bond. Once we break the double bond, right? It's gonna come here and here, okay? So what did we do to get the polymer? From the monomer into the polymer, we broke the double bond, and then it comes to the left and to the right. Now, remember how I put the N over here? Now you will get rid of the N over here. You will not put it over here, and you will put it at the bottom. Again, this was what? This is the monomer. In order to change it into the polymer, we broke the double bond. After breaking the double bond, before the N was to the side, we will now put it down. Very simply, this is how you locate the repeating unit. We'll move on to question number 16. A student is asked to find the pH of a solution. In an experiment, he prepares an aqueous solution of hydrochloric acid by dissolving 0.0800 mol of the acid in 250 milliliter volumetric flask filled up to the calibration mark at 25 degrees. This information is unnecessary. It's not going to help us. Only this and the fact that it's hydrochloric acid is going to help us. Why does hydrochloric acid help us? Okay, let's say, for example, we didn't have hydrochloric acid. We had sulfuric acid, which is H2SO4. What's the difference between hydrochloric acid and sulfuric acid? They're both acids. Like, what's the difference? What's the difference between? Like, what is the difference between them? You know? So very simply, if you notice, hydrochloric acid has 1 hydrogen, whereas sulfuric acid has how many hydrogens? It has 2. Now this is gonna affect the solving. If you don't pay attention to this, it's gonna affect our solving. HCl, we will be solving for how many moles? We'll be solving for 1 mole. Whereas the H2SO4 will be solving for 2 moles, right? This is why we have to pay attention to what we are dealing with. We're dealing with the HCl. We have only 1 hydrogen. So we're gonna be dealing with not 1 mole, 1 atom, let's say. Okay? So this over here is what? This is the number of moles and of the acid. And this over here is what? This over here is the volume. Of course, we will need to change the volume into liters. So let's change it into liters together by dividing by 1,000. It's going to be 0.25 liters. Now, here is the more important thing. Pay attention in the exam. If they give you, do they want the concentration of OH minus or H plus? In this case, they want the concentration of H plus. So it's very good. Why? Because we are dealing with hydrogen over here. Imagine if we were dealing with a base, NaOH. So this is H plus, right? This, we will leave it for after I solve the actual question. So we're looking for the concentration of H plus. Again, we are given hydrogen, right? And we're given what? We're given the number of moles, N, which is 0.08, and the volume, which is 0.25 liters. So how do we find the concentration? Again, remember the equation. N equals CV. N is equal to concentration times volume. We need to find the concentration. So concentration is equal to N over V, right? What's our N? Our N is 0.08 over our volume, which is 0.25. And you will get an answer of 0.32. But pay attention to the significant figures. It's 0.320. Now, how do we find the pH value? Very simply, one equation minus log what? Minus log concentration. This is how you find the pH. So in this case, you will put on your calculator minus log, okay? Then what do you have as our concentration? Our concentration for H plus in this case is 0.320, right? So you will put it on the calculator, minus log 0.320, and you will get an answer of 0.495. Now, this is to 3 decimal places, and this is what? This is our pH. Now, let's go back to what I asked before. Imagine if we had NaOH, okay? And it's with these exact, measures, and they wanted us to find the concentration of H plus. Very simply, you should know that the concentration of H plus, right, multiplied by the concentration of OH minus is equal to 1 times 10 to the power of minus 14. Okay, this is something that should be kept in mind, that concentration H plus times concentration OH minus is 1 times 10 to the power of minus 14. So again, let us find the concentration of H plus in this case. We have how many OH minus? In this case, we only have 1 OH minus. So how many moles will we be dealing with? We'll be dealing with like 1 mole or 1 atom, right? So 0.08, this is what? The number of moles, okay? And then 0.25, this is the volume in liters. Okay, we need to find the concentration. Concentration is number of moles over volume, which is 0.08 over 0.25, which is what? Which is 0.32 molarity, or the concentration. So the concentration of OH minus is what? Is 0.32 molarity. طيب, what if they asked you to find what if they asked you to find the concentration of H plus, knowing that you have the concentration of OH minus? In this case, what you're gonna do is you're gonna apply this equation over here. Concentration of H plus, which we need to find, times the concentration of OH minus, which is 0.32, okay, is equal to 1 times 10 to the power of minus 14. So move it to the other side. The concentration of H plus is then 1 times 10 to the power of minus 14 over 0.32. You will get an answer that the concentration of H plus is 3.125 times 10 to the power of minus 14. This is really simply like another case, which I'm sure might be coming. We're not sure, but I'm sure they might get something different in order to trick us. Now, question number 17. This is the thing I said that we haven't taken it before, but it's a bit confusing, a bit different than before, you know? I don't think that they're gonna bring it in the exam. If they do, in all cases, I will explain it. So, in an experiment, a student is asked to find the potential of a galvanic cell is made up of standard half cells of zinc and copper, right? Now, what are they asking us? They're telling us calculate the value of E net, specifying the anode when the reaction is taking place spontaneously. Now, what you need to know about the anodes and the cathodes is that they are never ions. Never ions. Anodes and cathodes are never ions. They're strips. They're physical things you can touch. They are not the ions that you cannot see with your eye. Right? Okay, so keep this in mind. Now, what do we need to know? We will look at these. These are called what? These are called the potentials. Right? These are called the energy potential. For example, this is the energy potential of zinc, and this is the energy potential of copper. One thing you need to keep in fact is that the more positive the energy potential is, the more reduced it will become. Right? The more positive the energy potential is, the more reduced it will become. Okay? Now, when we're talking about reduced, you will always link it to what? You will always link it to the cathode. And when we are talking about oxidized, then we are talking about the anode. And then what do they want from us? They want us to find the anode. So by looking at our given, which one is the more positive? The more positive is this one, because this is minus 0.76 and this is 0.34 plus 0.34. So the Cu, the copper, is more positive. Because the copper is more positive, it's going to be more reduced. And because it's more reduced, it's going to be what? It's going to be the cathode. Now, in this case, this means what? This means that the zinc is oxidized and that it is the anode. So the anode in this case is the zinc strip, not the zinc ions, the zinc strip. Now they want us to find the energy potential net of the cell. This is an equation you need to memorize. The energy potential net of the cell is equal to the energy potential of the cathode minus the energy potential of the anode, right? So energy potential net is equal to energy potential of the cathode. What's energy potential of the cathode? It's 0.34 minus energy potential of the anode, which is 0.76, minus 0.76, my bad. So it's going to be 0.34 minus 0.76, and you will get an answer of what? 1.10. So the energy potential net is plus 1.1 volts. We move on to question number 18. In an experiment, a student is asked to prepare a solution by dissolving 0.0600 mole of sodium bromide aqueous solution in a 10 milliliter water, right? An additional 40 milliliter of distilled water are then added to the solution. They want the concentration. Again, concentration is equal to number of moles over volume. What's our number of moles? 0.06. What's our volume? Our total volume, it's 10, and then we added 40, so it's 50 milliliters, which in liters is 0.05 liters, right? So it's gonna be our number of moles, which is 0.06 mole, over our volume, which is 0.05 liters. It will give us an answer of 1.20 molarity. So this is our concentration to 3 significant figures, 1.20. We'll move on to question number 19. Choose the correct answers to predict the effect of increasing the pressure by adding an inert gas. Okay, when you're dealing with the pressure, you always look at the gases on both sides, the number of gases on both sides. In this case, you have what? You have two gases. In total, how many gases? You have 2. And here, how many do you have in total? You have 2. So because the number of gases on the left side is equal to the number of gases on the right side, adding an inert gas is not gonna cause any change. So the equilibrium position is not affected and the concentration of all species remain constant. Now, finally, the last question. How many kilograms of H2SO4 can be produced from 8 kilograms of S8? Okay, this is a very simple stoichiometric question. First thing we need to do is we need to find the number of moles of S8. How do we do that? We take the mass in grams always. So it's 8,000 grams. Because it's 8 kg, divided by the molar mass. What's the molar mass in this case? It's 8 times 32. What is 8 times 32? It's 256. So 8,000 divided by 256. What answer will we get? We will get an answer of 31.25. So this is the number of moles of S8, right? But what does this mean? This means that one S8 gave me how many moles? It gave me 31.25 moles. What about 8 H2SO4? If 1 gave me 31.25, what about 8? How much will it give me? It will give me 8 times 31.25, right? So 8 times 31.25, it will give us an answer of 250 moles. So this is now how many moles? 250 moles of H2SO4. Now, how do we find the mass? Very simply, 250 multiplied by the molar mass. 250 times the molar mass of H2SO4, which is 32. No, let's start. First of all, 2 plus 32 plus 4 times 16, right? So 2 plus 32 plus 4 times 16. And we will get an answer of what? Of 24,500. This is in grams, but do they need it in grams? No, they need it in kilograms. So we will divide by 1,000, and what answer we will get? We will get 24.5 kg. So that is it for this video. Let's submit, and hopefully there are no mistakes. And thank God, as you can see, there are no mistakes. Thank you guys for watching. I hope you enjoyed, and have a wonderful day.